Hi, how are you? Today we continue to study geometry, and we study a few concepts and properties. Okay, the first concept we study is midpoint. So what is a midpoint? A midpoint is a point on a line segment. So first you know what is a line segment, right? A part of a straight line is a line segment, and a midpoint is a point in on the line segment that cuts the line segment into two equal parts. Okay, so that is called a midpoint. So for example, here point D is the midpoint of line segment BC. Okay, so what is the meaning? So mathematically, what is the meaning? The meaning is this, right? So the length of BD, or say DB, okay, is equal to DC, right? Is equal to the length of DC. So you can use a equation. So this length is equal to this length. So this is the mathematical language, right? Okay, so in maths, this is the mathematical meaning. Okay, so the midpoint. Okay, so then after you have learned midpoint, then we come to a new concept called median. So what is a median? Then in a triangle, first if you have a midpoint on the side, then from the opposite vertex, the opposite, you know opposite, right? So because this side faces that point, so this vertex is the opposite vertex. So from this vertex, you draw a you connect. Okay, you connect this vertex, this opposite vertex, and the midpoint on this side. So this line segment AD, this line segment AD is called the median. Okay, so what is median? Median easy, right? So now after you have got it, then it is very easy. But before you have remembered it, before you have understood it, median is a annoying name, right? It is very annoying, hard for people to get it. But after you have got it, then this is very easy actually. That is just in on the triangle on the side. You just find the midpoint first, and then connect the a vertex and the midpoint. Then this is called the median, right? Or say median is related to midpoint because both have a me, right? So midpoint or median, they are related, right? They are so similar. Even the two words are similar. Midpoint, mid, and median, right? Both started with an M, right? M. Okay. So median is the line segment connecting the midpoint and a vertex. Okay. So this is the median. Okay. Median is not the height. Okay. This dotted line segment is the height. So what is height? You still know, remember this, right? As an excellent student, you should know what a height is. But actually, some other students don't know. Okay, this is true. Many other students don't know what a height is. Okay, actually, it's easy, right? Height means a line segment from a vertex that is perpendicular with the base, right? Perpendicular with the base. Then this is called the or perpendicular with this opposite side of the vertex, right? Okay, so this is the height. Height has a key word called perpendicular, right? This is a perpendicular symbol, or say 90-degree symbol, right angle symbol. Okay, remember this. Some students do not know this, even at grade 10. Some of my students, before they met me, they even didn't know this when they were at grade 10. They didn't know what this is. Okay, this is a right angle symbol, right? Okay, only if you see such a symbol, you know this is a right angle. This this angle, although it looks like 90 degrees, but because you didn't see the right angle symbol, so this angle is not a right angle. Okay, got it, right? So only this angle E is a right angle. Okay. So perpendicular is the keyword of height, and median is not necessarily a right angle, right? Median doesn't necessarily make a right angle with the base. Okay. The key word of a median is the midpoint, right? It's the midpoint. Okay. Midpoint means the two sides. I mean the two line segments beside this midpoint, they are equal, right? So this is the midpoint, the meaning of the midpoint. Okay, so this is the median. Okay, got it, right? So what a median is, you know it, right? Now, okay, good. Okay, since you know, okay, for this half triangle, okay, sorry, a median cuts the original triangle ABC into two smaller triangles, right? So this smaller triangle ABD has an area only half as before, right? How come? Because the area is height multiplied by the base, right? Originally BC is twice of BD, right? Because D is midpoint. So BC is twice of BD. Okay, so now BD is only half. So only the base now is half. Height is still the same height. So the area is half, right? So this median cuts this original triangle ABC into two smaller triangles with both having the same area, right? So cut them into two areas of the same size, of the same quantity. Okay. So this ADC has the same area as ABD, right? So these two smaller triangles have equal areas. Okay. And then a second concept called midsegment. So what is a midsegment? A midsegment is this. On a triangle, you first find two midpoints. So find a midpoint of this side and find another midpoint of the other side. Okay. So you find two midpoints. So okay, so you connect these two midpoints, then it is a midsegment. Okay. Midsegment. Got it, right? So DE is a midsegment. Okay, so this is a midsegment. But why do we study this? Why do we study this? Because it is important. How important? What's important about it? Okay, so this is DE. This midsegment is parallel with the base BC. Okay, so this is the significance. Okay, this midsegment is parallel with this base. Okay, and another thing, this midsegment is half of this base. Okay, or say this base is twice of the midsegment. Got it, right? Since this is half of the base, then the base is twice of the midsegment. Okay, so this logic is easy, but some students find it hard. Okay. But for you, it's easy, I believe. Okay, so you got it, right? And since this is midpoint, so AD, of course, is equal to DB, right? And AE is equal to EC, right? Okay, so this is a midsegment. Okay. Then let's practice. So for example, calculate the length of XY. Okay, so XY, how long is it? 2, right? 2 cm. How do you know? Because this is 4. So that is half. Half is 2, right? Half is 2. So 2 is XY is 2. Okay. So this XY, how long is this XY? Since this XY is twice of this midsegment, right? So this midsegment has 6 cm. So XY is 12, right? 12 cm. Okay, 12 cm XY. Got it, right? Very easy problems for you to practice. After this practice, I think you have become more familiar with the mid-segment. Okay, so let's move on. Question. The area of triangle PQR, okay, where is PQR? PQR, okay, is 16 square centimeters, okay, square centimeters. Okay, so calculate the area of triangle PQS. Where is PQS? PQS. Okay, so this is smaller one, right? This is half one. Half one, of course, it is 8, right? So 8 square centimeters. So this is 8 square centimeters. How about the other? The other, what is the other? Triangle QSR. Where is QSR? QSR. Okay, so this is smaller one. This one is also half, right? This one is also half. So since this is half, then it is 8, right? So 8 out of half out of this, so it is 8. So 8 plus 8 is totally originally 16, right? Okay, good. Because this triangle, if you take this as the base, then this triangle and that triangle, they have this equal length of bases, right? And then their height is the same, right? Their height is the same. But here it may be QS, but not necessarily QS, because we do not see the right angle symbol here. So you can draw a perpendicular line, right? You can draw a perpendicular line through this point Q, okay, toward this side PR, and then they share the same height, right? So this triangle PS and this triangle SR, they share the same height, right? They share the same height. However, the base, this PS is equal to this SR, so they have equal bases and they share the same height. So they have the same area, right? So they have the same areas. Okay, so this is 8. This is also 8. And then the sum is originally 16. Got it, right? Okay, let's move on. Okay, then let's come to a third or fourth or fifth, okay, concept, right? A new concept. So today we learned many concepts, right? And you reviewed some concepts, right? So today we encountered many concepts. Okay, so this one is a very complex one, right? Centroid. Okay, centroid. This word is similar with center, right? So actually this is a center. Okay, so centroid is a center. Okay, centroid. Okay, centroid. What is a centroid? Centroid is this. It is a very what? Very remarkable. Yeah, very remarkable. How come? Because it is really remarkable or awesome or amazing or unbelievable. Yeah, incredible. Why? Because look, the coincidence is really I cannot believe it. The coincidence. What is the coincidence? It is this. First, you draw the median through A. So from A, you draw a point A. From point vertex A, you draw a median AE. Okay, because E is the middle point. So this side BE is equal to EC, right? Okay, and find the middle point F. So this side is equal to this side, right? So AF is equal to FC. You find the point F, and then connect BF. Then you get another median, right? A second median. And then find the point D, middle point D. That is AD is equal to DB. Okay, so after you have found this middle point D, then connect DC. Then this is the third median, right? Okay, the remarkable thing is that the three medians intersect at one point. Yeah, isn't this a remarkable coincidence? They intersect at one point, and that point is named G, or say centroid. So that central point is called centroid. So if you are asked to summarize, so what is a centroid? So the centroid is the point of intersection of the three medians, right, of a triangle. Okay, so that is centroid. Or say the intersection of the three medians. So if you answer very briefly, then that is just the intersection of the three medians is the centroid, right? Okay, the centroid. The other thing more remarkable about centroid is that for any centroid, I mean any random triangle, if you find the centroid, then the centroid has such a remarkable property. That is, the centroid cuts all the three medians into two parts, right? So for example, AE is a median, and this median is cut by point G into two parts, one longer part AG and a shorter part GE, right? Okay, so now the shorter part GE is half of the longer part AG. Okay, isn't this remarkable? And the longer part BG is twice the shorter part GF. The longer part CG is twice of the shorter part GD. Okay, so all the three medians are cut by the centroid into two parts, with the shorter part half of the longer part. Okay, or say the longer part twice as the shorter part. Got it, right? Okay, now I just tell you, and I'm not able to prove it for you, because now you are just in grade 9, you are not able to understand. And in grade 10, in analytical geometry, by calculation, you are able to calculation in a coordinate system. That is analytical geometry. You study geometry in a coordinate system, then that is analytical geometry. In analytical geometry, you are able to verify or prove that a centroid has such properties, such remarkable properties. Okay, got it, right? Okay. Then let's move on to this, the remarkable thing of the mid segments. So the remarkable thing of a mid, how come I say the mid segments? Yes, they are. Okay, so for example, first, quadrilateral ABCD is a random quadrilateral. So you can draw a random quadrilateral. So four sides randomly make a quadrilateral ABCD, the outer one, the outside one, the greatest one. Okay, and then find the midpoints of the four sides. So for example, here E, F, G, H. Okay, so these are four midpoints, and then you connect these midpoints to get four mid segments, right? So these four mid segments make a new quadrilateral, right? And then this new quadrilateral is a what? I let you guess. A parallelogram. So any the mid segments, the four mid segments of any random quadrilateral make a parallelogram inside. Okay, so let's prove. It's easy. Okay, you draw a red diagonal of the original quadrilateral. Okay, you draw a diagonal here, and then the diagonal cuts the original outer greatest quadrilateral into two triangles, right? So in this triangle, in this inverted triangle, this HE is the mid segment, right? So this mid segment is parallel with the base, the red line, right? Okay, is parallel. So this one is parallel with this one, and this HE is half of this BD, right? Half of this BD. Okay. How about the GF? Or say FG? FG also, right? The same reason, because this is the middle segment. So it is parallel with this red line. And it is also half of this red line, right? So this one is parallel with this red. This one is also parallel with this red. So this HE is parallel with this FG, right? Okay, now they are parallel. Okay, so these opposite sides are parallel. And they are equal, right? How come? Because this GF is half of this DB. This HE is also half of this DB, right? So both are half of this red one. So both blue sides are equal, right? So this HE is equal to this GF. So GF is not only parallel with the HE, but also equal, right? So they are both parallel and equal. So a pair of opposite sides are both equal and parallel with each other. Then this shape, this quadrilateral, is a parallelogram, right? Okay, so proved. So inside is a parallelogram. So the middle segments, the 4 middle segments of any quadrilateral can make a parallelogram inside. Okay, so this is a property. You need to remember it because this is so remarkable that it's easy for you to remember, right? Okay, good. Okay, so let's move on. Let's move on to a new topic. Okay, our final topic actually for today. The diagonals of a parallelogram. Okay, so the diagonals. So you draw this first. This is A, B, C, D is a parallelogram, right? And then now you draw the diagonals BD and AC. Okay, so the two diagonals intersect at a point, right? That point we can name it point E. Okay, and then you can use congruency. Do you still remember the congruency of triangles? In grade 7 or 8, you studied and practiced a lot, so you need to remember it. Okay, you still remember it, right? Okay, if you remember, okay, let's prove it. Since this side is equal to this side, right? Since this is a parallelogram, and this side is parallel with this side, right? Okay, so this angle I pointed, this angle is equal to this angle, right? Alternate angles equal, right? And this angle D is equal to this angle, right? Alternate angles, right? So angle means A, right? We use A to abbreviate to stand for angle. So S is side, right? AS A, right? Because this angle equal to this angle, this side equal to this side. This angle equal to this side. Okay, so ASA. Okay, use 3 letters. You are able to prove congruency, right? ASA, you can do it. So this triangle is congruent with this triangle, right? Okay, since they are congruent, then what? Then of course this side is equal to this side, and this side of this triangle. This side of this triangle is equal to this side of this triangle, right? Okay, so now since this side is equal to this side and this side is equal to this side, so what does this mean? This means this point E bisects the diagonals, right? Or say the two diagonals bisect each other, right? Okay, so the slogan. Oh, no, not slogan. Yeah, okay, you can say slogan or say the formula. The song, the saying of a parallelogram is that, right? The two diagonals of a parallelogram bisect each other, right? This is the law, the sentence for you to remember. The law, the theorem. Okay. The diagonals of a parallelogram bisect each other. Okay, so this is the property of the diagonals of a parallelogram. You remembered it, right? You need to remember this because this will be used in grade 10 analytical geometry and will appear in the final exam. And if you do not remember it, then you will fail. Okay. If you do remember, then you will get a high mark. So for example, 90, 95 or 98 or something. Okay, good. Let's move on. Yeah, this is just to review, right? To summarize the things we learned today. Okay. So this means a random quadrilateral. Okay, so the midpoints, you connect the midpoints of a random quadrilateral, and then you get a parallelogram inside, right? Okay, so this sentence says describes this figure, and this figure shows what I said. Okay. Okay, and then this one is just one sentence, right? The diagonals of a parallelogram bisect each other, right? Okay, so you still remember this. Okay, so let's move on. This is the final page we are looking at. Okay, so what does it mean? Or say what do these shapes mean? First, let's move from the right side to the left side. Okay, so let's start with rectangle. So the diagonals. Now we are paying attention. We are paying attention to the diagonals of these quadrilaterals. These special quadrilaterals. So the diagonals of a rectangle. What is special about them? Okay, they are equal. Okay, a rectangle is also a parallelogram, right? So first they bisect each other. Of course, all of them. A square is a parallelogram. A rhombus is a parallelogram. A rectangle is a parallelogram. So all the diagonals bisect each other. This is the first thing. And then the second thing is for a rectangle, in a rectangle, the diagonals not only bisect each other, but also what? But also equal. They are equal with each other, equal to each other. How do you know? You still use the congruency of triangles. So for example, this triangle, this right triangle, and this right triangle that is lying here. Okay, so these two right triangles, they are congruent. How do you know? Because this side is equal to this side. This side is equal to itself. This angle is equal to this right triangle. These two right triangles are equal. So side, angle, side. So that is SAS 3 letters. You can prove congruency. So this facing down right triangle, and this facing up right triangle, they are congruent. Since they are congruent, then this hypotenuse of this facing up right triangle is equal to the hypotenuse of this facing down right triangle. Okay, since they are these two hypotenuses are equal, then they are diagonals actually. So these diagonals are equal. So they are not only equal, but also they bisect each other. So for a rectangle, this is these are the properties of their diagonals. So how about the diagonals of a rhombus? Okay, a rhombus is different from a rectangle. Because there are no 90 degrees here. But the sides are equal, right? Okay. So the special thing is that first the two diagonals of course bisect each other, and then the second special property about them is that the two diagonals are perpendicular with each other. How do you know? You can still use congruency to prove. So for example, this triangle, this is small triangle, and this neighboring one, and this neighboring triangle. So they are congruent. How do you know? Because this side equal to this side, right? And this side equal to that side, right? How come? How do you know? Because they bisect each other, right? The diagonals bisect each other. So this side is equal to this side. And this side is equal to itself, right? This side is equal to itself. So side equal to side side, right? So S, 3 letters, you can prove congruency. So this one is congruent with this one. Since they are congruent, then this angle is equal to this angle, right? These two angles are equal, and the sum of these two angles is 180 degrees, right? This is a flat angle, straight line. So 180 divided by 2, so this is 90, right? So this is also 90, so 290 degrees. Okay, since 290 degrees, so this 90 degree means what? Means perpendicular, right? So the two diagonals of a rhombus are not only perpendicular but also bisect each other. Okay, so how about a square? Since a square is both a rhombus and a rectangle, right? So it has all the special properties. So the diagonals are equal first, and then they bisect each other, right? And then finally they are perpendicular, right? They are perpendicular to each other. Okay, so proved. Okay, so this is the end of the study of today. Okay, thank you very much. Okay, good luck, and I wish you good luck, and you are a excellent student. Okay, thank you. Bye. Have a nice day. Bye.